Hi everyone, welcome back. Today we're going to be looking at section 5.3. This is lesson 1 and we're going to be looking at slope-intercept form. So today we're going to work on writing and graphing linear equations in slope-intercept form. You will need a notebook and pencil, and then if you do have that pad of graph paper, you're going to need that as well. So let's get started. First thing I want to talk to you all about are what parent functions are. So a family of functions is a group of functions with common characteristics. So we can relate that back to your family, right? In most cases, families share common characteristics. So for my family specifically, my mom has blonde hair and my dad has blue eyes. Well, I share both of those characteristics with my parents. So that's kind of the same idea. We're going to have a group of functions and they're going to share very similar common characteristics as well. A parent function is the simplest function with the characteristics. So the linear parent function is f of x is equal to x. Also sometimes written as y equals x. And that is the blue line off to the right. So if I plugged in 0 for x, y is 0. If I plug in 1 for x, y is 1. It's very, very basic. Nothing's manipulating the graph in any way. Then we're going to look at some linear functions. So a linear equation is an equation that models a linear function. So f of x is equal to 2x is a linear function. So notice this graph has changed a little bit. It's steeper compared to the last one. It's because we're multiplying x by 2 now. So this is part of that family of functions. It still is a linear function. It's still a straight line. It's just now it's changed slightly. So it's being multiplied by 2. So unlike before, if I do 1 times 2, I get 2. So now we have the coordinate 1, 2. So it's like moving up more. It's becoming more steep. Then we have some other examples I want to look at with you guys. So in purple, we have f of x is equal to x squared. That is not a variable function because the variable is being raised to a power other than 1. And then f of x is equal to 2 raised to the x power. That's not a linear function because the variable is the power, and we don't want the variable to be the power. Okay, so just so you guys can see what those look like. That is the purple one where we have x squared. That is still a parent function. That is actually a parent function for the quadratics, which hopefully we'll be looking at in chapter 9. And then looking at the f of x is equal to 2 raised to the power of x. That is an exponential function. So if you notice, it's like kind of curving up. And in this case, that one we'll be hopefully looking at in chapter 7. And that is not the parent function of that one, just so you guys know. Okay, so looking here at slope-intercept form. So the idea is we are taking f of x and replacing it with y. So the slope-intercept form of a non-vertical line is y is equal to mx plus b. M is your slope and b is your y-intercept. So let's do some practice. The first question is asking to find the slope and the y-intercept of each linear equation. Well, looking here, I know that slope is always going to be next to the x or attached to the x. So in my first case, my 5 here is attached to my x, so that is going to be my slope. So I'm going to write m is equal to 5. Then that pretty much opens it up for my intercept, which is our b value. We just have to look at the other number that is in the equation. So the only other number we have is -7, so that is my intercept. You can do the same thing for number 2. I have my x, and it's being multiplied by -2/3, so that means my slope is -2/3, and then that leaves my intercept to be 9. And it's really important you always associate the negative or the plus sign that's in front of the number when you're writing, right? So in the first one, that was -7. So the intercept is -7. That was -2/3 in the second one with slope. So we have to make sure we put the negative. Okay, if you write it positive, it changes what kind of slope we have and what kind of line we have. So then the next one is to write a linear equation in slope-intercept form given the following information. So if you remember, our slope-intercept form is y is equal to mx plus b. So we're just going to be plugging in for m and b. So y is equal to, I'm going to leave a space, and then my plus, and then same thing over here. So looking here, my slope here, my m value is 6. So I can actually plug that in next to my x, and then my y value is my -1/2. So I could leave my plus sign and write it as -1/2, or if you choose, you could write it as x or 6x minus 1/2. Either way works. Then looking at the next one, my slope here is -4/5. I'm going to plug that in there. And then my slope here, or I'm sorry, my y-intercept is 7. There we go. There's my two equations written in slope-intercept form. The next thing that we can do is actually write the slope-intercept form represented by the line shown. So first thing that I always find to be easiest is to determine your actual intercept. And if you remember, that is where the line is hitting the y-axis. So if we're looking here, we are actually hitting the y-axis right here at +3. So without doing any work, I know that my intercept is 3. Now with slope, you could do this a couple different ways, right? We're given the graph and we're also given 2 points. So depending on how you want to do it, you could go based off the graph or the 2 points. I'll show you both ways. So if I'm starting at my first point here, which just so we have it is -3, -6, and then my second point is 0, 3. I am going to go up and then right. And then we can count the boxes. Well, to go from -6 to 3, that's actually 9 spaces. And then to go from -3 to 0, that is 3 spaces. And they're both going up and right. And up and right are both positive values. So knowing that, my rise over run for this would be 9/3, or simply 3. If you wanted to use the coordinate points, you could do that too. So I could do my 3 minus -6 divided by 0 minus my -3. That turns into 3 plus 6, which is 9, and then 0 plus 3, which is 3, which reduces again to 3. So you could do either method. It doesn't matter. Notice we got the same answer. So the last part is to just plug it into our slope-intercept form. So I'm going to have y is equal to my slope times x plus my intercept. So my slope was 3, and my intercept was also 3. And there we go. That is our equation. Let's practice doing another one. So this one's slightly different. Again, I'm going to start with my intercept, which I notice is hitting right here at +1. So my b value is 1. And then I'm just actually going to use the graph to help me find my slope. So in this case, we are going down and right. Well, down is always negative, and we're going down 1, 2, 3. So this is a -3 for our rise. And then we're going right 1, 2, 3, 4. Wait, hold on. 1, 2, 3, 4, 5, 6. So my rise, again, was -3. My run was 6. And this can then reduce to -1/2. So that is our slope. Again, I can plug this in. So y is equal to then x plus my slope is my -1/2. And then my intercept is 1. Notice the graph is going downhill, so our slope is negative. Okay, then looking at this one's a little bit different. Okay, for this case, I am actually, if you notice, looking here, right, this is a vertical line. And my vertical line is not hitting the y-axis at all. So in this case, we actually do not have an intercept, right? So this does not exist. It's not hitting. So I'm going to put not touching y-axis, right? So we don't have an intercept. And then if you notice, right, we have the 2 points. Well, in this case, I'm actually going to use our slope formula to figure out the slope. So this is the point 4, 4, and then this is the point 4, -4. So if I plug this into into our slope formula, I have -4 minus 4 over, and then it's going to be 4 minus 4. So if we do this out, right, -4 minus 4 gives us -8, and 4 minus 4 gives us 0. So hopefully this was reviewed a little bit, but as a quick reminder, it is okay to do 0 divided by a number and we get 0, but it is not okay, or no, you cannot do a number divided by 0. And this gives us undefined. So given here, right, we have -8 divided by 0, so this gives us an undefined slope. So this is a very specific case where we actually can't use slope-intercept form to write this example. So what ends up happening is we are actually going to go based off of the axis it's on, okay? If you notice, this line is on it's going through the x-axis, right? It's going through it at 4. And so what ends up happening is our equation turns into x is equal to 4. So when you have a vertical line, you're going to look at where it's hitting the x-axis, and you're going to put what value it's hitting at. If you notice, if I picked any point on that line, every single x value was 4, okay? So then let's do one more. This is a horizontal line, and we can actually write this one in slope-intercept form. So if you're noticing, it is hitting the y-intercept, or the y-axis right here, and it's hitting at 4. The next thing we can do is actually find the slope as well, and I'm going to use the 2 points. So the first point is -6. Oh, I'm sorry, the intercept's -4. But it's -6, -4, and then we have 4, -4. And again, just using our slope formula, I can plug in and solve. So we're going to have -4 minus a -4. Be careful with your negative signs. And then we are going to have 4 minus a -6. Well, -4 minus -4 turns into -4 plus 4, which gives us 0. And then 4 minus -6 gives us a +10. And since this resembles our okay, we get the value 0. So when we go to write this, I've let my students write it either way, but I'm going to tell you which one's the preferred way. The first way is to actually write it with your slope, right? So we know our slope is 0, and we know that our intercept is -4. And I've had students write it like this because they like seeing that the slope is 0. But the preferred way is, if you remember, right, anything times 0 is 0. So 0 times x is 0. And if we add 0 to -4, we still get -4. So you could just simply write it as y is equal to, and then -4. That's also okay. The preferred method is going to be this one, right? It looks very similar to the other one, right? When we had that vertical line and it was hitting the x-axis, it was x is equal to 4. Well, same thing here, right? This is only hitting the y-axis, and if you notice, every single point, the y value is -4. So very, very similar, right? Y is equal to -4. That's the preferred way, but if you write the one above it, I will obviously accept that as an acceptable answer because it is true. Just keep that in mind. Okay, and I do believe, yep, that is it for today's video. If you have any questions, please reach out. We'll be doing some more practice in class, and I will see you all later. Bye, guys.